That's why 50 to 60% of the time, repeat testing is also going to lead in failure. Of all this, one condition that you should be very clear about is obesity. Because if there is obesity, there is an inverse relationship to the amount of fetal fraction that is going to be present in the mother. Now, in obese women, what happens is that you have a large turnover of cells happening. And because of that, the cell-free DNA that is going to be there in the mother's blood is going to be extremely high. And because of the volume of the mother's cell-free DNA, the amount of fetal fraction is going to be proportionately less. It is not because there is poor placental function or because there is aneuploidy that there is low fetal fraction in obese mothers. It is because the quantity of maternal DNA is going to be so high that it is going to drown out the cell-free fetal fraction that is going to be present in the mother's blood. And that's why if you have an obese mother who has a high BMI or who has a maternal weight that is above 78 or 80 kilograms, you should probably think twice before sending her blood for NIPT. Now, once we have looked at all that, we've looked at the no-call rate and the possibility of low fetal fraction, now let us look at the real question. What is the detection rate of NIPT? Is it actually 99%? Let me give you an example here. If there are 1 lakh women, and let's say that there is around 200 babies with Down syndrome in that group of 1 lakh women, and if there is a no-call rate of around 3% because of low fetal fraction or technical failure, 3% of the time if you get a no result, what will happen is that 3,000 euploid pregnancies will have a no result on NIPT. 6 babies with Down syndrome will have a no result on NIPT. So out of the total 200 that you had with trisomy 21, only 194 will be picked up. So your end detection rate would be 194 divided by 200, that would be 97%. So the real life screening performance of NIPT would be somewhere around 96 to 97%, which is not as high as the 99% that is usually talked about. This is because the no result rate or no call rates are sometimes not included in the statistics. But what happens if you have a no result on NIPT? If you have a no result on NIPT, you can again try and repeat the NIPT test again after 2 or 3 weeks, but 50% of the time you will not get a result. Now, when you get NIPT showing a no result rate, you're worried about aneuploidies because that is one of the common reasons why you will get a no result rate on NIPT. So then you will be forced to do an unnecessary invasive test. Now, in the example that I showed you, 3,000 euploid pregnancies would have an unnecessary invasive test if the NIPT comes out as no result. The last option, and probably the worst option, would be to do a quadruple test, which has a low detection rate, when you already know that the combined test has a much higher detection rate, and which was the test you could have done, which you missed out because the NIPT showed a no result. So remember that no result on NIPT actually opens up a Pandora's box, and therefore, if that happens, you need a backup plan. And I'll tell you what that is shortly. So on NIPT, you can get a no-call rate, but also NIPT is going to have false positives and false negatives as well. The false positivity on NIPT could be because of a number of factors like confined placental mosaicism or vanishing twin, maternal mosaicism, maternal copy number variants, maternal malignancy, and transplant recipients. Let's look at each of them one by one. Confined placental mosaicism means when you have an abnormality that is confined to the placenta. Now, when does that happen? If you have an embryo that was trisomic to begin with, as you can see here in this example, this embryo is abnormal because it's got a trisomy in it. Now, it can continue as a trisomic pregnancy where you will have an abnormal placenta and an abnormal fetus, or it can undergo a phenomenon called as trisomic rescue, where the placenta remains abnormal while the fetus becomes normal. Or even the opposite can happen, where the placenta is normal and the fetus is abnormal. Now, when the placenta is abnormal, the cell-free fetal fraction from this placenta is going to be picked up by the NIPT, and it will say that the baby is abnormal. And here, the NIPT test will say that the baby is normal, but the baby is actually abnormal. And that is a big problem in NIPT. So because you have this difference in the karyotype or difference in the abnormalities that are present in either the placenta or the fetus, there is a possibility that the NIPT may become normal and the fetus can be abnormal, or vice versa. So when you are confronted with an NIPT test that is abnormal, you're worried about this, and that's why most of the people advocate an amniocentesis at 20 weeks to solve this problem. But that is not always the case. You can go in for CVS after a positive NIPT test if the NIPT turns out to be positive for trisomy 21. This is because confined placental mosaicism is extremely rare for trisomy 21, and therefore you can go in for CVS. As far as 18 and 13 are concerned, they usually have a scan finding. So if you have an NIPT test result that turns out to be positive for 18 or 13, and you find that there are scan findings that are telling you that this baby is abnormal, you can go in for a CVS. On the other hand, if you find that the baby is completely normal and the NIPT result is saying 18 or 13 positivity, then amniocentesis would be the best option. And also, when you have sex chromosomal abnormalities picked up on NIPT, then amniocentesis is the best option. So an amnio for trisomy 18, 13 and sex chromosomes with no scan findings, whereas CVS for all cases of NIPT with trisomy 21 positivity or 18, 13 positivity with scan findings that you can pick up on your 11 to 14 week scan. Another cause of false positivity is a vanishing twin. Now, a vanishing twin, even after the twin is no longer there, its placenta continues to secrete cell-free fetal DNA into the maternal blood, and that cell-free fetal DNA can cause an abnormal result on your NIPT. Especially, it creates a problem when the vanishing twin has not been documented. Now, 10 to 39% of all your multiple pregnancies after ART can have a vanishing twin. It's around 0.6% in the general population, and 15% of your false positivity on NIPT is due to a vanishing twin. So what does that mean? Does that mean that for a twin pregnancy in which one baby has died in the early first trimester, you cannot do any form of screening? It's not. There is a way to solve this problem. Now, even in a vanishing twin, over a period of time, the placenta stops secreting DNA into the mother's blood, and whatever DNA was there in the mother's blood also begins to disappear. And it has been shown that it is the least after 14 weeks. So for a vanishing twin, the amount of DNA or fetal fraction that is present due to that vanishing twin is the least after 14 weeks. But even then, there is a false positive chance of 2.6%. So if you look at this graph, you can see that the fetal fraction keeps on decreasing, and it is the least after 14 weeks and keeps on decreasing and almost disappears from the maternal blood 8 weeks after documented demise. So what we do at our center, and that has been described by most places, is that you can offer NIPT after 14 weeks in cases where there is a twin with single fetal demise, and at least 6 weeks after the documented demise. It should be after 14 weeks and preferably 6 weeks after the documented fetal demise, because that gives sufficient time for the cell-free fetal DNA to disappear from the maternal blood. Another condition that can cause false positivity is maternal malignancy. Now, you should suspect it when an NIPT result shows an abnormality in multiple chromosomes. For example, you did an NIPT for a mom and it came out positive for 21, 1, 2, 6, number of other chromosomes. Now, this happens because of malignancy, because a tumor cell within the mother continues to shed cell-free DNA into the maternal circulation, and it will be having multiple chromosomes, and therefore there will be an overrepresentation of a number of chromosomes within the NIPT result. And here you should suspect malignancies, and rather than thinking that the fetus is abnormal. Maternal copy number variants, which are basically small deletions or duplications within the genome of the mother, and if they are sufficiently large, it can be picked up on NIPT, and trisomy 18 is notoriously known to create this problem because of maternal copy number variants. Lastly, maternal mosaicism, especially in sex chromosome aneuploidies. Now, as a woman grows older, one of her X chromosomes is going to get switched off automatically. And because of that, it is going to create an underrepresentation of the X chromosome. So when the NIPT test is done, it will show an underrepresentation of the X chromosome. And because you think that the mother is normal, you will attribute that abnormality to the fetus. And that's what happens, especially when you do an NIPT and it turns out to be positive for Turner's syndrome. The same thing applies for all sex chromosome aneuploidies, actually, because here the critical assumption that the mother is normal fails. Because mild forms of sex chromosomal aneuploidies, especially the mosaic forms, can be totally undetected in the mother, and that can be picked up when you do an NIPT.